Right, so for this video, we are going to have a look at these thermochemistry calculations, which pop up on question 6. There's one every year. The last 2 years, they've kind of trying to throw students a bit by moving away with kind of strange enough compounds that are being combusted or being made. And in this case, it's just looking at tetraethyl lead and the combustion of that. Things you got to know about it. These in general, these calculations, that a combustion reaction always involves oxygen, all right? And if you're combusting a hydrocarbon, which is just a compound containing carbon and hydrogen, the products are always going to be carbon dioxide and water, all right? So it'll be the compound burnt in oxygen, and you're producing carbon dioxide and water if it's a hydrocarbon. But for this one, it's slightly weird because it's actually that tetraethyl lead. Okay, so there's an extra product in there in this particular reaction, and that is lead oxide, PbO. All right, so what they're asking you to do is to calculate the heat of reaction for combustion of 1 mole of tetraethyl lead, right? And that's actually really important at the end, because what they're giving you here, you see there straight away that that's 2, right? So what the equation they've given you there is actually for when 2 moles of tetraethyl lead is burned in oxygen, all right? So that's important at the end of the calculation, right? So let's look at how we're going to solve this problem, yeah? And the good news is that all the information is contained that you need is contained in that question there, yeah? So if we go through them left to right, so you've got, these are all heats of formation, so all these numbers are heats of formation for those 4 compounds there, right? So if something's being formed, right, that compound is always going to be on the right hand side, right? So you're given the formula, you don't even need to know the formula, you're given it, right? So that's tetraethyl lead. Okay, so that's being formed, right? So you've got, what you have to know is what it's being formed from. So what elements is that going to be formed from there, right? So the first one obviously there is lead, Pb. Next one is carbon, right? So C. And then the last one is the tricky bit. Okay, so that is hydrogen, right? So it's being formed from hydrogen. And hydrogen exists in nature in the form H2, right? Carbon exists as carbon, but hydrogen, oxygen, they all exist as O2 or H2, yeah? Now, the last thing you've got to do is balance this off, right? So Pb is okay, there's 1. Now, how many carbons have you got? 2, and you've got 4 of them, right? So it's going to be 8, okay? And then hydrogen here, you've got 5 of them. 5 hydrogens, there's going to be 4 of them, so that's 20. So it's going to be 10 H2, right? So that's the first one, right? So that's going to be formed. The delta H for that is 52.7 plus 52.7. Okay, that's the first one. Now the next 3 are easier, which is good to know. Next one, carbon dioxide, CO2, formed from carbon and oxygen. And the delta H there is minus 393.5. Okay. Next one then is water, which is H2O. That's formed from hydrogen, which is H2, and it's also formed from oxygen, which is O2, but you must put in a half there, yeah? So that now is delta H is going to be minus 285.8. Okay, and the last one then is lead oxide, which is PbO, and again that's formed from Pb, and it's also going to be formed from O2. You make sure you put the half in there, and your delta H is going to be minus 219. Right. Now that's the first part. Okay, now this is where it gets kind of similar to simultaneous equations in maths, right? So you've got to rearrange things so that you're going to get this target equation in the end. That's what you're looking for, right? So you've got to look at these 4 equations here and see where they pop up in this target equation and rearrange them accordingly. So if you look at the first one here, right, so we've got tetraethyl lead here in our target equation. It's on the left hand side though, right? So this here is on the right hand side. So the first thing that you need to do is reverse that. Yeah. Also there's 2 of them in the target equation, so you're going to have to multiply that by 2 as well. So this we're going to have to multiply by 2 and we're going to have to reverse. Yeah. Next one, carbon dioxide, right on the right hand side, which is good. They don't have to reverse it, but we've got 16, so we need to multiply this figure here by 16. Okay. Next one then, water, again on the right hand side, that's okay, but we've got to multiply that by 20 this time because there's 20 of them in our target equation. And last one then is lead oxide. We've got to multiply that by 2 because there's 2 of them in our target equation. All right, so let's apply that to all of these, right? So if we reverse and multiply by 2, we end up getting 2 tetraethyl lead. Okay, and reversing that, so now we're going to have 2 Pb, we're going to have 16 C, and we're going to have 20 H2, right? And our delta H is now going to become, you're going to have to reverse it, so you're going to have to change the sign on that, and multiplying it by 2, it's going to be 105.4. Okay, sorry, it's going over there now. I'll have to move this around a bit. Okay, can you see that? Now, next one. Then we're going to have to multiply this, so it's going to be 16C plus 16O2. And that's going to give us 16CO2, right? And then we got to take the delta H into account here. We multiply that by 16 and we get minus 6296. Okay, that's going to be important for the calculation at the end, right? Next one then is going to be H2, so it's going to be 20, multiplying by 20 H2 plus 10 O2, okay, and that's going to give you 20 H2O. Right, so again, multiplying this by 20, right, you end up getting minus 5716, right? So that's your delta H. Last one then, Pb, 2 pp plus 1 O2, okay, half by 2 gives you 1, and then that's going to give you 2 PbO. Right, in this case your delta H is going to be minus 438. Okay, nearly there. Alright, now the beauty of this method is that everything is going to cancel now. Everything that you don't need is going to cancel. So you look down through all your equations here. You've got 16 carbons here and you've got 16 carbons there, right? So that cancels, yeah? You also have 20 hydrogens here and you've got 20 hydrogens over here. So that cancels. Okay. You've got 2 Pb here and you've got 2 Pb there. And that cancels, right? So you're nearly here. You pretty much are at your target equation now, right? So if you just rewrite it out, so you get 2, right, tetraethyl lead plus 16 plus 10 plus 1 gives you 27O2, which is what you need. Okay, and that gives you 16 CO2 plus 20 H2O, and then finally plus 2 PbO. Alright, and now the important thing then, to get your final answer, you need to add up all 3 of these, right? So I'm just going to write to delta H for the first one here again, so you can just see me adding them all up. So it's 105.4. Okay, So if you add up all of them, you get a grand total of minus 12,555.4, right? And the important thing then is, you know that it's 2 there, so you must divide that figure by 2, and you get a final answer of minus 6277.7. And that is your answer.